Welcome to another live CTF recording of pwnable.kr. Pwnable.kr is a standard wargame CTF kind of challenge, and it says here in the rules and tips that you shouldn't post solutions online, but if you insist, post the easy ones and do not spoil too much. So what I'm doing is I only play a couple of the early levels, and they are already online. You can find solutions already online, so I don't feel too bad of making a recording of it. But definitely play them yourself if you got the time, because you will learn a lot more. So let's have a look at the first challenge. You can see with the dotted border of that level that I've already solved it. But the other levels are new. I just thought after solving that one up, maybe would be a good idea to record those. So I copy the SSH credentials from the challenge description, and then I log into this machine. The first thing I do is obviously look up what files exist, and I see that there's a fd program and the source code fd.c. And when we execute it, it also tells us that we can pass a number to it. And if we look closely in the code, we see that the argument that we can pass to it is converted to an integer, and then it's subtracted hex 1234 from that integer. And that is stored in fd. And then fd is used in the read function call as first parameter, which is the file descriptor, and it reads 32 characters from buff. And afterwards, buff is string compared to let me win. So what we want to do is somehow we want to get this fd value to 1, because we want to read from standard input, and standard input is the file descriptor 1. So basically we want to enter a number that is hex 1234 plus 1, that after the subtractions the result is 1, and then read is called on file descriptor number 1, and we can type in whatever we want as a string, and that is read and then compared, and it's correct, and then we get the flag. That was a bit fast, but just go back and look exactly at it yourself. So up to the next level called collision, and it says here Daddy told me about MD5 hash collisions, so let's see what it is about. We log out of the previous challenge and log into the next one. So let's again check what files are available. Again, there's a program called call, and there's source code available for it as well. And let's have a look at it. So first, the argument count is checked if it's smaller than 2, because it needs a passcode to supply, and you can see it when you execute it, it wants a passcode. Then it checks if the passcode you entered is 20 bytes long. If not, it makes an error. But if it's 20 bytes long, then it will call check password up there, which has a little function, a little for loop going over the passcode that you supply, and it's calculating some integer value, and it's then later compared to the hash code. So it's kind of like a simple hashing algorithm. Not quite MD5, but some kind of hashing algorithm. So we want now to find a way to collide those hashes. Basically, we want to provide an input that will create the same hash code. And we can now look at this in disassembly to see, maybe to figure it out how exactly this algorithm works. The for loop does add some values, so it makes sense to create a breakpoint at the add instruction to see exactly what kind of values are added on this hash that is generated, to see maybe how it works. So again, we have to start the program with 20 characters, so we can just simply use a pattern that we can easily recognize in the function, and we hit the breakpoint. So let's look at the registers, and yes, the value should be an AAX that is added. So we see that in the first round it's A's, and the second time it's B's. So apparently it's just looping over the passcode that we supply, in always 4 bytes at a time, and then just simply adds the hex value or the number representation of those bytes. And then the result has to be the hash code. So now I try to think away what would be an efficient way to get to this hash collision, those calculations. So first, make a quick test by passing the passcode via a Python inline script to see if that works. I know that it works. I don't know why I did this at this moment. I was probably just, thinking. Then I thought I need 5 pairs of 4 bytes to add up to this hash code value. So, I'm so intelligent, why not make all the pairs 0 except for 1, and then we add basically hash code on it, and then it's all fine. While writing this, at some point I realized, wait a moment, this cannot work, because the argument will be checked with string length if it's 20. And if I have 0 bytes in there, then string length will not have this length anymore because strings end on a 0 byte. So it would just be 0 length. So that wouldn't work. Then I realized, I need 5 equal parts. So, or like I need some equal parts, so I just divide this by a number. And then I realize I could just, add the division result of this on top of each other 4 times to reach this number. At this moment, I didn't realize that I made a mistake, that it has to be 20 long, so it needs to be divided by 5 and not by 4. Thus, my attempt right now of using 4 times this value doesn't work. But, I will realize that in a second. So I think at this moment that 4 times this string would allow me to pass this test, because 4 times that would add up to the hash code value. But obviously the passcode should be 20 bytes, and oops, I did it with 4 instead of 5. So let's check again, how can we divide this value by 5? And I realized, damn, it's not it has a remainder, so I cannot simply divide this by 5, but I have to slightly change the single values so that it matches. The next idea I have is I could simply add up a certain value like hex 1111 4 times and then add the remaining stuff on it to reach the hash code. But I realized that 111 is already too much and that there's a negative value. So basically I have to make the value that I add up 4 times a bit smaller, and I decide on I could also just use hex 010101. This means that this is the amount for the 5th 4-byte pair to add up to the hash value. So I make hex to get this value. So if I have 4 times 010101 and then this 1 DDD at the end 1 time, those will all add up to the hash code. So that's what I'm doing now. I'm specifying to print the hex 010101 4 times, and for the 5th time then I add this value that I calculated with the subtraction from the hash code, this 1DD, because those will then add up to the hash code that we want. And notice here that we have the endianness, so we have to basically specify the bytes from the reverse order. And congrats, we created a hash collision. So we can use this flag and see if it's correct, and yes, we receive some points for it. Next level, BOF. Nana told me that a buffer overflow is one of the most common software vulnerabilities. Is that true? So let's have a look at this. We can apparently this time download the file instead of having a SSH to connect, because then we connect with Netcat, as you can see there in the description. So we have to analyze the binary locally and then use this to exploit the remote binary. So now I open Hopper to load the binary in Hopper. I should have probably looked at the source code first, because we did get the source code, so I don't know why I opened it up in Hopper immediately. Okay, so I'm still not looking at the source code, and yeah, that's the Netcat. We can connect to this server, and it says overflow me now. Okay, so let's look at it. So main calls func with a certain number, and then this key is compared if it's different. So it passes dead beef, but inside the function func, it checks if it's Cafe Babe. So somehow we have to change the key. But as you can see, this function never changes the key. So this is a common buffer overflow. We have to overflow a certain value so that we can overwrite the local variable key on the stack. I created some more extensive videos about how a buffer overflow works and how those local variables are stored on the stack and stuff. So check out my hacking instruction playlist where I go into this in more detail. Basically what we want to throw a lot of characters at it so that it's overflowing the buffer and then overwriting the key with a value that we want. I'm now going on this server before just to be on the same system so I can debug this, because I obviously am on a Mac machine and I need a Linux machine so I can test some stuff. And instead of opening up my own virtual machine with Linux, I just want to use the machine from Pwnable. But I think they prevent you from using wget or generally connect to services from inside those servers. Not that you use it for like as a botnet to DOS somebody or something. So I use SCP to upload the binary to the server. Then we can connect to it again and then start analyzing this binary. Obviously, TMP is not readable because there are other users on the system playing the same game, and if you could read TMP, you could read and see what other people are doing. But we know that we uploaded BOF, so we can now analyze this here. So we want to make a breakpoint at the compare of the function. So there's a disassembly of the function, and so we can run it, and then I failed to make it executable, so do it again. We set a breakpoint at the compare where we compare the key to the specific number. But I get still some weird errors. It's executable, but still some weird errors. So at this moment, I'm a bit confused. So I create my own directory because TMP is, not readable, and maybe GDB has a problem with it. And but inside our own directory, we can now read. So I try it again. Yeah, and now it seems to work. So let's create here our breakpoint in this GDB session. First of all, disassemble the function again, just so that we can see it nicely. And then we create a breakpoint at this address. So we start this and we type something in, and now we hit the breakpoint, and we can look at the registers. And if you look in the disassembly, it loads the value from EBP plus hex 8, and that value is compared to Cafe Babe, so it's still dead beef, obviously. So it's restarted again, and let's create a pattern so that we can see with what part we can overflow maybe the key variable. So we hit the breakpoint, we can look again at this address, and apparently we have overwritten the key with 4e, 4e, 4e. And you can use Python to see that 4e is the character n. So apparently this many characters resulted in is the padding or the offset, and then from that on we can write the specific value. So what we want is basically we want to write until m, and then basically we want to write the Cafe Babe. And again, I cannot simply just copy this because I need to do it from backwards. So it's ending with BE, and BA, FE, and CA. And then I throw it against it, but I forgot the pipe. Stack smashing detected, terminated. Why is that? Stack smashing detected means that there was a stack canary, a certain special value on the stack, and if that gets overwritten and the function tries to return, it will simply terminate. So I have somehow overwritten this value, which is clear because we have overwritten stuff on the stack. But if you look at the source code, we shouldn't return, we should have the shell before. So we have to use this trick with cat, because the echo will close the input, and with this cat together we can still have open the input, and we can then read the flag. You can see the same technique used in other videos of mine if you don't know that one. Okay, up to the next level, and that is called level flag. Again, this is apparently a reversing challenge. We only have a binary file. You can check it's a 64-bit ELF Linux executable. So basically, first thing, checking the strings, maybe the password or the flag is already in it. And it says here this file is packed with the UPX executable packer. So this is a strong indication that obviously it's UPX packed and we need to unpack it. And that we find so much random garbage is probably because it got is packed with UPX and it creates a lot of random strings. So now I do decide to start my VM because maybe I need some more debugging or reversing tools. So, and that's why I need a Linux machine. And I go in the share folder. The share folder is shared between the virtual machine and my Mac, so I can place some files in there and work on them on both machines. But I can also simply just download the flag again. So now I just install UPX because that should allow me to unpack this binary or decompress or whatever. So I look in the man page and try to find again how exactly you decompress or unpack a UPX packed binary. I search for like unpack and extract and try to find what the parameter was again, but I cannot find it. So I quickly search online again how, maybe it says somewhere else how it works. And then decompress, and then I find maybe UPX minus D. So UPX minus D, and minus T is a flag and tested and it finds, yeah, this one is UPX packed. So if with minus L we can, oh no, with minus L we can check if the flag is, if it's packed with UPX. I think I missed the minus D to decompress, that's why I'm looking around here. It was right there, but I must have missed it, so I'm searching again. Manual unpacking, of course, that's interesting. Very interesting. I've never done it actually, but you know, if you know that a tool works, then sometimes you just use it. Okay, now I see it. It's UPX minus D. And yeah, it unpacked one file. Cool. So we can look at it again, and it's not packed with UPX anymore, so it got unpacked. So now we can do a strings on it, and yeah, that looks much more normal and common for a normal binary. So this is weird. There's a lot of stuff in this binary. That's a bit interesting. So maybe let's just execute it. First have to make it executable. I will malloc a string copy the flag there, ticket. Okay, so it will string copy the flag somewhere. This means it will be then later in memory. So let's analyze this binary a little bit. Obviously, we can also open it in Hopper. Now I'm going to my tools, to the Vagrant Share folder, and open the flag. Okay, here's main. Takes a while to analyze. It's a very loaded one. I don't exactly know what's in there. Maybe some interpreter or something. I don't know. So now I'm looking for string copy because it said it would string copy the flag. But we cannot find any references to string copy, so not so sure what I do now. Flag is also no results. Okay, so this seems to be the main function where it prints the stuff. So this is the real main here. And yeah, we can also see the malloc here, so that's cool. And maybe this one is the string copy, the questionable call there. So we just break at the end of main. Now we are there. So now we can just look around. And then I'm looking around and I see that on the stack there, it looks like that there's a string. Because where RIX is pointing to, and it says UPX sounds da, but now I get annoyed because pwndebug or GDB cuts the string and doesn't display the full string. It makes me very annoyed right now. And I have no idea how to tell GDB to please print the whole string. So what I do now is, I have an idea. I could maybe go via the proc file and just cut the process memory, but that doesn't work. And maybe, and I actually don't know if, I'm not sure if that worked. Like, I thought that you could simply read the memory of a process like that, if you are root, but maybe I have to look into this again. Now I'm thinking maybe it was not mem, maybe it was a different file in proc, but it says it should be mem. But then I realized, I have to know where exactly it's mapped in memory, and I have to probably seek to those special addresses and stuff. So that's not as simple as cat. Then I think about maybe with print I can something, and then I can maybe do printf to just print this as a string. But I don't really know exactly the syntax, how that works with GDB. Maybe like regular printf? No format string missing. But luckily there's an example. So it is without parentheses. No, just the correct parameter, and there it is. UPX sounds like a delivery service. And that's the flag.